All right, this is geometry section 4.1 to 4.2 on classifying triangles, and we're going to classify triangles in two different ways. First, we'll classify by the number of sides that are congruent. None of the sides are congruent, we call it scalene. If two or more sides are congruent, we call it isosceles. And if all three sides are congruent, we call it equilateral. So note on the isosceles, it says two or more congruent sides. So an equilateral triangle is also considered isosceles, but equilateral triangle is a more precise name if all three sides are congruent. We also classify it by angle, classify it by its largest angle. The largest angle is bigger than 90 degrees. It's an obtuse triangle. The largest angles are 90-degree angle to right triangle. And if the largest angle is less than 90, it is acute. And note that in all of these triangles, you have the two smallest angles that will always be acute. And so you're just looking at the largest angle to determine what kind of triangle it is. Terminology, we have interior and exterior angles. Interior, obviously, inside the triangle. So with this drawing, you can see that 3, 4, and 5 are interior angles. And an exterior angle is an angle that forms a linear pair with an interior angle. So angle 2 would be considered an exterior angle, whereas angle 1 is not because it's just a vertical angle to that interior angle. If I put angle 6 right here, that would also be considered an exterior angle. Next up, we have the triangle angle sum theorem, which basically says that the three angles in a triangle sum up to 180 degrees. So in our diagram, the measure of angle A plus measure of angle B plus measure of angle C adds up to 180 degrees. And here is our proof of that. I'd like for you to try this proof on your own before you look at mine. But here's what the proof looks like. In order to make this work, we're going to draw in an auxiliary line, line BD. And the restrictions we're putting on this is that it goes through point B, and this line is parallel to AC, which gives us our given over here. And from there, you can follow the rest of the proof. And this also leads to what's called the exterior angle theorem. This is one of those step saver reasons. An exterior angle like angle 1 is equal to the sum of the two remote interior angles. So we could say that measure of angle 1 equals measure of angle 2 plus measure of angle 3. And following is a proof. You can pause your video and look through the reasons and the steps in this one. The given isn't very much in this one. We don't need to have a lot for this one. Normally we wouldn't even mention this, that this is a given, but we need to put something in our given. And we can see that through these reasons that the measure of angle 1 would be equal to the measure of angle 2 plus measure of angle 3. The next few examples are all solving for variables. In each one of those, we're using the triangle angle sum theorem. We're using, in this case, because these angles are equal to each other, isosceles triangle are congruent angles, so those have to be equal to each other. Vertical angles, complementary angles, and example number 5 has a little bit more involved. So the drawing might not quite look like it based off of the markings. Each of these angles are equal. They add up to 180, so they're all going to be 60 degrees. 70 degrees is the vertical angle to this one, so this entire angle is 70. We've used up 60, so that has to be 10. Got the same thing going on over here because of the congruent angles. And then in this entire triangle, we have 180 degrees. We've used up 70 and 70, so that means that there's 40 degrees left, split evenly between those two. 20 plus 10 is 30, which leaves 150 for this angle. Same thing in our triangle on the right, so W would then be equal to 150.